ArcSan is now digital.ai. Join us at our booth in the virtual expo hall to learn how our app protection, white box cryptography, and threat analytics solutions can help you stay ahead of the evolving threat landscape.
Welcome. Today, I'm going to help you navigate this alphabet soup of scanning tools: SAST, DAST, IAST, RASP, and AST. First, I want to start by thanking Trupti Shirlakar for basically reviewing these slides and providing updated input to help me have more up-to-date information in these slides. So thank you, Trupti. All right, so one of the things that I notice people making as a mistake when they're choosing a scanning tool is the first thing they do is they look at the scanning tool and go, or they hear about it from someone and they say, wow, this is a great tool. Joe Bob says it's really good and it's gonna, toast your bread and make you breakfast and find all your security vulnerabilities. But that is the wrong way of going about things. You're actually putting the cart before the horse. So the first thing that you want to do when you're trying to evaluate which of these tools to use is you've got to understand what you're scanning. And when you're trying to understand what you're scanning, you have to ask yourself several questions. One is, what language are you going to be scanning? Or languages are you going to be scanning? Are there any particular frameworks that are associated with those languages? What is it that you're scanning? Is it a web application? Is it a mobile application? Is it a library or some esoteric piece of code that is not seen very often, like a trustlet in a trusted execution environment or a smart card applet? Each one of these things are going to have different limitations by different scanning tools and their ability to do a good job in finding vulnerabilities in those areas. So to give you an example, web applications are pretty well supported, but mobile applications are going to be difficult for DAST and IAST and RASP, and we're going to discuss why. And if you're dealing with things like trustlets, well, most scanning tools don't have researchers that are writing rules to find vulnerabilities in those type of applications. So if you try scanning your apps, your trustlet apps, don't expect to find anything besides quality issues. So there are some things that are in common for all of these tools that you have to understand and assess for each of these different alphabet soup tools. And each will have their own unique weaknesses, but then there are also common characteristics that you're going to need to understand for each of these tools individually. Like, for example, how many rules does the tool have for your language or your framework? And what type of vulnerabilities are actually covered by that tool for your language and your framework and your architecture? And you need to know how well the language is supported, because some of these tools say they support a specific language, but when you actually go run them on the language, your results may vary. Also, frameworks have specific entry points that they define. And if the tool that you're using doesn't know about your framework, well, then it's not going to be able to trace the data flow entry points through your application to the vulnerable sinks that are going to cause exploits. And so you need to know if the frameworks are supported by the tool and how well. And how well is the question of how many rules they have and how well they support the underlying language that the framework is built on. The other thing is you have to understand what architecture is required by the tool. So for example, with IAST and RASP, you need to have an agent running in your application. And that's going to be very difficult to do in a trusted environment or a mobile application. The other thing is all of these tools to a certain extent are going to struggle with finding business logic vulnerabilities. So you may want to write your own custom rules. And if you're going to write your own custom rules, you need to know what level of custom rules the tools support. So some tools might support custom rules that are simple grep scripts. Other tools may have custom rules which allow you to manage state, control flow, look at your code and set up variables that other rules can build off of. And finally, you want to understand how well these tools are going to integrate with your CI/CD pipeline. Because everything today in app security is about shifting left, getting security in earlier within your processes, and making sure you get security and find those problems in as early as possible when it's cheaper to fix. The other thing that's very important is to include your developers and your QA staff in the selection of these tools. And the reason why is because they're going to be the ones that are going to have to use them, that have to integrate them. You want your developers feeling good about the tool and the results, and you want QA involved because, for example, a dynamic application security testing solution, you want them to feel comfortable actually using that and integrating that into the QA process so they become your security army. And we have the whole organization focused on security. So let's start looking at each of the tools individually. Let's start with static analysis because that is one of the first things that came out. And when you look at it, the advantages, if the language is supported well and you give it all the source code, then it's going to give pretty decent results if the rules are there. Now, the thing is, when I say you give it all the source code, what I mean by that is that if you have third-party libraries, one of the functions of a static analysis tool is to do data flow analysis. And if your data flow happens to go through a third-party library that's only in binary form, and if it doesn't have pass-through rules, then the data flow analysis stops there. And it won't find any vulnerabilities where the data flow passes through those libraries and ends up in a sink. Now, the other advantage of static analysis is that it will scan all the theoretical code paths when you're within your application. So from a code coverage perspective, it's going to give you a lot of findings. In addition, custom rules can be used to support a framework or library or one of those esoteric programming models like trusted execution environments where you want to find buffer overflows and integer overflows. The other thing is that it works with mobile applications as well. From a disadvantage standpoint, it cannot scan through binaries unless you give it pass-through rules. And it doesn't find any of the vulnerabilities in those third-party binary libraries. There is a modification to this called binary static analysis, but we're going to talk about that next. The other disadvantage of static analysis is that it tends to have a high number of false positives. And it's highly dependent on the rules and the coverage of those rules for your language or framework. So what you're going to find is if you have a very niche framework or language, you may not have good support in static analysis. Then the other thing is there are some inherent tunable parameters which is going to affect how deep the static analysis scans, to what level, how long it's going to take. And those are things that are going to require very specialized knowledge to tune properly. So now if we look at binary static analysis, what we're doing is we're scanning the binaries. And it's going to do well for supported languages as long as you give it all the binaries. Now, The one advantage of binary static analysis is that it's going to find the vulnerabilities in your third-party libraries. And it works with mobile applications. From a disadvantages standpoint, you're not going to be able to perfectly correlate when a vulnerability is found in binary to where it is in the source code, because some of that information is lost in the translation process. It also has high false positives, and it also is dependent highly on the quality and coverage of rules, and has the same disadvantages as static analysis. So now let's move on to dynamic application security testing. So one of the advantages of DAST is that it can see across your server pipeline because it's sending in a payload, which is going to travel across the server pipeline, invoke your business logic, and get a response. And so it's going to find vulnerabilities that aren't going to be found by tools that are very focused on one component of that pipeline. So for example, HTTP request smuggling, or parameter pollution, or cache poisoning. These type of vulnerabilities won't be found by the other tools because they're very focused on just living in one of your servers instead of looking at that whole server pipeline. The other advantage of DAST is minimal installation and configuration to get started. You basically install the software, point and click, you're ready to go. It doesn't require any type of source code integration. It's easier to get integrated into the build process. It can inherently work across language boundaries because it doesn't care. It's just passing in a payload. And today, modern DAST tools are improving in reducing the number of false positives. In the past, there were a lot of false positives because basically it was difficult for the tools to differentiate between an error and having a payload that actually triggered the error that it thinks it's triggering. And today, modern DAST tools actually have some specialized business logic scanning capabilities for things that are well known, like multi-page authentication flows, shopping carts, etc. Now, when we talk about disadvantages, well, it's difficult if an application is coded correctly in terms of returning non-disclosing error messages for a DAST tool to actually understand if the payload that it sent in was causing that vulnerability or some other. So if you have an XPath injection vulnerability and you pass a SQL injection payload to it, well, it's going to return an error. But the thing is, you don't know if that error was really caused by the fact that if there's a SQL injection vulnerability behind this or XPath. So what you'd find is a lot of false positives and a lot of vulnerabilities that were cited for the same URL path. When you're looking at these tools, your code coverage is going to depend on how well the spidering logic of the DAST tool works. Sometimes it's very difficult in modern applications to know how to navigate and where to go to find different pages that can be exercisable. Now, today, there are DAST tools that utilize Swagger documentation APIs that will basically give it what URLs to attack or look at the framework artifact components that give it URLs to attack. And so it's getting better. So if we talk about IAST and RASP, we basically have an agent that's going to instrument your code to basically watch input being passed into your application, trace it through to a sink, and report those vulnerabilities as findings. It's basically a better DAST because it has knowledge of your code. So it can avoid all the false positives that a DAST may report. And it's going to require an agent running in your code. So from an advantages standpoint, there's going to be higher fidelity in terms of the findings, because you know that the only things that are going to be reported are the exploitable paths. Now, in contrast with a SAST tool, static analysis tool, it's going to look at every logically reachable point in your code. And so maybe there may be some dead code or some other paths that don't make sense in your code that may report findings. The other thing that's nice about RASP is that you can use it to block attacks at runtime. And typically, when you're trying to onboard IAST or RASP in your application, it is easier. In terms of the disadvantages, well, code coverage is going to be based on what you test. So if you don't test it, you're not going to find it. It does require an agent, which is going to limit where you deploy to. It doesn't work with languages that don't have a runtime, like C and C++. And there is a slight to noticeable performance hit due to the overhead of instrumenting the runtime code. And in some cases, it's going to be worth it to use, and in other cases, you may not want to. If you're dealing in a high volume financial website where even 2% or 3% degradation in performance is going to be a lot of money lost, well, then maybe this isn't the route to go. But if you're the DoD and you've got budget and you've got a lot of servers and you want to protect them all, this may be a good choice. The other thing with these tools is that the ability to write custom rules may be dependent on the vendor and the language supported by that vendor. The other thing is it doesn't work with the front end part of mobile applications. And it may be difficult to find vulnerabilities in single page apps because you would have to write an agent that would run in your browser to find those vulnerabilities. So when we look at manuals code reviews, you're going to do that when none of the tools support your language or your framework or library. So this would be something like smart cards or trusted execution environments. However, with even trusted execution environments, for example, with static analysis, you could write custom rules yourself that would taint the entry points. Like for trustlets, you would want to write a rule for TL main and taint those parameters so that you can do data flow analysis. But that would allow you to support trustlets or smart cards, basically writing custom rules. Also, when you're looking at complicated business logic vulnerabilities that are specific to your company's domain, that may be something that you're going to have to do manually because of the fact that the security researchers on those teams that are writing the rules for the tools don't have any knowledge about what specific threats you're facing. And just going back, to making sure the tool supports your language or framework or programming environment. And if it doesn't, you might have to go to fuzz testing or manual source code review. The other thing that's come out recently is software composition analysis. And basically, this is finding vulnerabilities in your third-party libraries. Some tools basically look at the jar files and identify the versions of, or not just the jar files, the requirements.txt or the CocoaPods, whatever it is that has your third-party libraries that you're using and the versions, and then are going to report if any of those libraries have CVEs associated with them. The problem with these tools is that they're not going to tell you if you're actually using those vulnerable APIs within those third-party libraries. So you could get a lot of false positives. And so there are some tools like white LightSource is one of the few that actually support languages where they will look in your code and tell you if you're making the appropriate calls to the third-party library's vulnerable APIs. So you want to keep that in mind because you may get a lot of false positives. And this is looking at a different thing than your, what the other tools are doing. This is looking at your third-party dependencies. And some of the other tools, like the DAST, have now features where they can find certain third-party library, vulnerable third-party library components. So you got to do your homework. So if we think about an overall process for selecting a tool from all these, from the alphabet soup of scanning tools that you can choose from, you can always kind of start with asking yourself this question of, are you working with a niche language? And is it supported by any tool? If not, then you're going to have to do manual code review, or you're going to have to write custom rules, or use something like fuzz testing. The next question you want to ask is your application a mobile app? Well, if it is, you can use static analysis for the front end, and then for the back-end components, you can use pretty much any of the other tools to scan your code. If it's a web applications are traditionally pretty well supported, but you still need to know if the tool supports your framework and the language. So Python is kind of notorious for having poor support. Sometimes Ruby can fall in that bucket. But there's some open source tools like Brakeman for Ruby that are actually pretty decent. So know what you're getting into. And then sometimes there are some applications that do cross-language interactions. And so, DAST, manual code review, or SAST with custom rules may be able to handle that if the SAST engine can handle tacking flows together across different languages. If all of your flows are going across different runtime languages, well then IAST and RASP may be able to work as well. If you need runtime protection, well, RASP is the only show that's going to work for you. And the other thing to consider is when you're looking at IAST and DAST, IAST is going to be a little bit better, but at the same time, it's probably going to cost more because of it. So you got to look at your ROI when you're trying to choose between those two. And if it's not an application, web application or supported runtime, well, then you got SAST or manual code review. Now, once you've selected which of these tools you want to use, the generalized category, well, the next step is to then select among the vendors. And so when you are looking at different vendors, you want to assess them based upon having high true positives, meaning actually finding real results, having low false positives, meaning not reporting a bunch of things that are wrong or that aren't really real vulnerabilities. You also want low false negatives, meaning you don't want it to miss a lot of stuff. The other thing, as I pointed out to in the beginning, is that you want to have a tool that the developers and the QA engineers are going to buy into, are going to feel comfortable using, are going to trust the results, because then they're going to be more willing to fix the reported vulnerabilities that are output by the tool. You're going to also want to look at how well the vendor integrates with your pipeline. And because developers, you want to get them involved in being part of the security solution, the whole organization and the QA people, it's important to look at how well the vendor explains the vulnerability. Is it going to be something that a developer or a QA engineer is going to be able to read and understand? Also, you want it to be able to integrate with your bug tracking systems. And if it can handle business logic, you will always want to consider that because it allows you to standardize how you're handling some of your business logic vulnerabilities. And then finally, you want to calculate your overall return on investment.